Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's lecture, I will be looking at differential equations, and particularly I'll be looking at solving differential equations using variable separable method. So we solved few problems in our previous lessons, so we want to solve additional problem now. So this is the 17th problem we are about to solve. So if you have issues with understanding the method of variable separable, you can watch the previous problems that we did solve. So let's look at this problem. So the first thing we can do, since the x and the y are already on both sides of the equations, we can now decide to just deal with the factors that are attached to the y and the x. So since this is the x, it means every other variable here must be in x. Since this is in y, we must divide it by, on both sides of the equation, 1 minus y. So this 1 minus y will go out. So the next area is that this side is the y, so everything here must be in y. So this x must go out. So it is only this x, in fact, that we are taking out of the problem. So we divide both sides by x. So this and this cancel. Oh, sorry. Okay. So on this side now we have 1 minus x squared all over x dx equals y times 1 plus y dy all over 1 minus y. So that's the first step. So ensure that we separate the variables. So after the variables now have been separated, the next thing to do is to ensure that we have the integral now of each side of the equation. So we integrate this side and we also integrate this side. So the integrated side is just very simple. The integral of, we take the integral of like 1 over x dx. So we do that separately. The integral of x squared over x, dx. So this is the first part. Equals. Now we can multiply. So you have a y times y is y squared and y times 1 is y all over y plus 1 dy. Now when we're doing integrations of rational functions, we told you that whenever you have a rational function, when the numerator's power is greater than the denominator's power, the first thing you do is to apply long division. Also, when the powers are the same, you can still apply long division. And when the power of the denominator is greater than the numerator's power, you don't apply long division. The only thing you do is that you try to factorize the denominator, or you bring in partial fraction decomposition. So since this power down here is just 1 and this power is 2, that is, this is less than this one, we can apply long division. So to do that, we have 1 minus y plus 1 is outside the divisor, and the dividend now we have y squared plus y plus 0. So we say y minus y into y squared is like minus y into y squared. So it's like saying y times y divided by negative y. So this and this cancel, you still left with negative y. So it's negative y. So we must multiply that negative y number each term here. Negative times negative is positive. Y times y is y squared. Negative y times positive 1 is negative y. We attach negative. So this and this now will go out. Negative times negative is positive. Y plus y is 2y. Okay, plus error. So we continue until this first term cannot go into the first term any longer. So y into 2y is just by saying minus 2, because like minus y go into 2y. So this and this cancel, you left with minus 2. Minus 2 times minus y is positive 2y, and then minus 2 times 1 is minus 2. So we attach negative. Isn't this cancel? Negative times negative is positive, so it's just 2. Now, whenever you divide or dividend by a divisor, your result now becomes the partial quotient. So let's deal with this one first. 1 over x is just the ln of x plus, okay, it's minus x squared over x, so we can reduce it. It will just be x dx equals, so this result now is equal to the partial quotient, which is the numerator here, the expression on top is minus y minus 2, the partial quotient, dy, then plus the remainder is 2 divided by the divisor. The divisor is minus y plus 1 dy. So now we have ln of x. So this is x squared over 2. We can integrate each of these. Integral of y is just y squared over 2. This is minus 2y. Now we can factor out this negative. So if we factor out that negative, we will have this to be positive now and this to be negative. That is, you can do it right down here. We could do it right down here first, and then before bringing it up. So we just took it up immediately. So dy. So we have the ln of x minus x squared over 2 equals minus y squared over 2 minus 2y minus 2 the ln of y minus 1 plus some arbitrary constancy. So maybe we can just further simplify them. So we have this. Maybe we say, okay, let's get rid of all of the denominators. So we multiply all by 2. 2 times this is 2 ln of x minus x squared. But you could call this your answer, your general solution. So this time this is minus y squared. This is minus 4y. This is minus 2 of, that's a full ln of y minus 1 plus 2 arbitrary constancy. So further we could, let's say, bring this y term across. So we have y squared is positive now, positive 4y, right? And then we could, yes, further bring those expressions on this side. So we have positive 4 ln of y minus 1. And then let's say, okay, so all of the terms now have been sent on this side. Then this, we'll forget this one, plus 2 ln of x plus 2 arbitrary constant. So these two, we will combine them, all equals to 0. So those two, we can combine them. We have y squared plus 4. So the first thing, maybe we would like to say, okay, y and y, we factor out 1y. So y plus 4 plus, we just simplifying this thing further. That's all. So we got ln of y minus 1 raised to the 4th power because of this, plus ln of x squared plus 2c equals to 0. So this entire 2c, we will just represent it by some constant called e. Or we could even call it ln of e. The reason is because we want to further simplify all of these ln into one ln. So y plus 4 plus, now when you have addition, it all ends into multiplication. So it's ln of e times this, so it's a x squared times y minus 1 to the 4th power. equals to 0. So we got this as our solution for the differential equation. So thanks ever so much for watching. Please don't forget to subscribe and hit the notification button for more videos. Like the video, you can share. Yeah, thank you. See you.